Okay, so here's our first question on checkpoint 28. We have this figure here and we want to know what is the volume. So if I look, I can see a triangular prism, right? Here's a triangle and then here would be that base and it's kind of just shifted on its side. So the formula that we want to use here is 1/2 base times height. Okay, so we're essentially going to be multiplying all three of these numbers together and then dividing it by 2. So when we multiply all of these together, we could just type it into a calculator. And let me pull one up. So I have 1/2 times 3.5 times 7.2 times 4.1. And I get 51.6. So volume of this figure here would be 51.6. So again, remember that when you are solving these problems that are asking for volume, it's crucial that you remember what your formulas are. Okay, without your formulas, it's going to be much harder to answer these. All right. Next problem here says that the object below is made of 9 rectangular prisms. Each one has dimensions of 16 by 10 by 7. What is the volume in cubic inches of the object below? Okay, so we have 9 of these boxes that are all the same, and I know that each box is 16 by 10 by 7. So volume formula for a rectangular prism is going to be length times width times height. So I'm going to have 16 times 10 times 7. So let's type that in. So I get 1,120. Now that's for one box. If we look here, it tells us that there are 9 rectangular prisms that all are going to have the same exact volume. So all I would need to do is multiply 9 times 1,120, and that gives me 10,080. So the volume for all of these boxes together would be 10,080 inches cubed. And to get that, we multiplied this by 9 because there are 9 of those rectangular prisms. All right, number 3. So for number 3 here, we have this box and we want to know what is the volume in cubic inches. Now this is where you have to be careful because if I notice only one of my units is in inches, right? This is in feet and this is also in feet, which means I need to change them to inches before. So there are 12 inches in 1 foot, right? So if I have 2 feet, I would have 24 inches. 2 times 12 would give me 24. So 2 times 12 gives me that 24, and 3 times 12 is going to give me 36. So the actual dimensions of my box, all in inches, is going to be 8 by 24 by 36. And then all I need to do is plug that into my formula. So 8 times 4 times 36. Oops, not 4, 8. 8 times 24 times 36 is going to give me 6,912. Notice that, hopefully you'll start to notice that every time we are finding volume, we are always taking 3 numbers from whatever shape we have. On that first problem we did, we multiplied 3 of the numbers from our figure into a formula. Here we're doing another 3 numbers. So every time that you see a volume question, you should be taking 3 numbers from your figure and multiplying them together, but always double check your units. Okay, the course loves to change the units on you to make you have to convert them first. So always double check your units. You want to make sure that you're doing your units before you plug it into your formula. Okay, so units are always first. All right, next one here, this is number 4. So here we have this box and we have a cube inside of a box, we want to know what is the volume inside of the larger box and outside of the smaller box. So what we would want to do is find the volume of both and then subtract them, right? If I find the volume of this big box, that includes that tiny cube that's in the middle. And then if I find the volume of that cube and subtract it, it's kind of like almost like I'm taking that cube out and I have all this area around it. So let's find the volume of both. So volume of big box first, length times width times height, 8 times 9 times 5. And let's plug that into our calculator. So that gives me 360. And then the volume of my cube is still going to be length times width times height, except my cube all has sides of 2. So I would have 2 times 2 times 2, and that would give me 8. You can double check it if you would like. 2 times 2 times 2 gives me 8. So now the last thing we need to do is our subtraction, which would be 360, and we're going to subtract that from 8. So 360 minus 8 gives me 352. So the volume of the space inside of the larger box but outside of the smaller box is going to be 352 centimeters cubed. So don't forget to do that subtraction piece at the very end to take out that cube. All right, number 5. So on number 5, Jeremy has 2 similar rectangular boxes, and box 1 is 3 times as wide and 5 times as tall as box 2. How many times greater is the volume of box 1 than box 2? Okay, well, if I were to take that 3 and 5, multiply them together, 3 times 5 would give me 15. So you were correct on this one. Good job. So that box 1 would be 15 times bigger than box 2. And again, all we need to do is take 3 and multiply it by 5. So 3 times 5 would give us that 15. All right, number 6. So here we have a composite figure, and let's see how Becca found her volume. So first she finds the volume of the cube on the bottom by multiplying 10 times 10 times 10 to get 1,000. So that sounds about right. I would do 10 times 10 times 10, and when I multiply all those, I get 1,000. Then it says that she multiplies it by 1.5 to get the total volume of the figure. Is she correct? Why or why not? Well, think about this triangle up here. This triangle is kind of slicing it in half, right? If I were to have a cube and I sliced it diagonally, that's what it would look like, right? And if I'm multiplying it by 1.5, this is kind of way back to when we were doing percents and things like that. This 1.5, so this 1 here, this represents my cube, and this 0.5 represents my triangular prism that's on top. So this represents that triangular prism, because if you think about it, that triangular prism is half, and 0.5 is the same as half. So this actually would be correct. So yes, she did find the volume of the triangular prism, and it is half of the cube. So this would actually work out, which is kind of a cool trick if you have a question like this with a cube on it on your exam, or if you see one in the future. So this would actually be correct. All right, number 7. So on number 7, we have a composite figure, and we want to know what the volume is. And notice how it's asking us in cubic inches, which means that anytime we see feet, we need to change that to inches. So I'm actually going to do a screenshot of this and then edit the photo here. Okay. So here is our figure. This 1 foot on the bottom, remember there are 12 inches in 1 foot. If I were to have half of a foot, half of 12 would be 6. Okay, so now I need to find the volume of this shape. And since it's a composite figure, we kind of need to do a little bit of visualizing to see where I can cut my figure. I'm going to cut it to make 2 boxes right here. So if I were to cut it right here, I would have that bottom flat box, and then I would have the smaller, taller box on top, sitting on top of it, okay? So let's find the volume of the bottom box first. So this is the one that I'm outlining in blue here. So let's find the volume of this very bottom box. Notice how I drew it all the way back, because technically that's where the box goes, right? It goes all the way to that back corner. So volume of that big box is going to be length times width times height, and that's these 3 numbers. So 12 times 10 times 4. And let's pull open a calculator to help us multiply all those. And I'm going to get 480. Okay, so now let's find the volume of that smaller box on top. Ooh, lime, sure. Okay, so now I'm going to find the volume of this box up here that I am highlighting. Now this one is a little bit trickier because I know 2 of the sides are 6 and the other one is 7, but I don't know what this bottom length is here. But if I look down here, this bottom side is 10, which means that this length here will also be 10. Okay, they're the same exact width, right, when I place one box on top of the other, which means that if this bottom side is 10, then this side here will also be 10. So volume of that figure is going to be length times width times height again, which I would be multiplying 10 times 6 times 7. And this is going to give me 420. I can double check it, but I am pretty sure. Yes, it does give me 420. Okay, cool. So now we know the volume of each shape, and all we need to do to figure out the rest of it for composite figures would be to add them together, right? So I would do 480 plus 420, and when I add them together, I should get 900. So the final volume of this shape would be 900. So we'd want to type in 900 into that blank. And again, you have to make sure that you're double checking these, because if you don't, then if you didn't change these units, you will not get the right answer. And you can't change it after because you have a mixture, right? So always double check what units your question wants and make sure that you convert those first. All right, number 8. So on this one, you got this one correct. Awesome job. So it says that Hannah's suitcase has these following dimensions, and we want to know what's the volume of Hannah's suitcase. So a suitcase, if you think about it, is a flat, like, box shape. So that would be a regular rectangular prism. So all we would need to do is multiply all 3 of those numbers to get 7,938. So good job. All right, number 9. So we want to know, we want to find the volume of the wood base and the post in inches. So again, we want inches, right? If I look at this figure here, I see feet and inches, but that's not what we want. We want to make sure that it's all in inches. So I'm going to take another screenshot here, and we're going to convert before we start plugging in anything. Okay, so this 6 feet here needs to change to inches. Remember, to do that, I'd multiply it by 12. So 6 times 12 is going to give me 72. And feel free to type that into a calculator to double check. This 2 on the bottom is going to give me 24 inches. And this 2 will also give me 24 inches. So let's find the volume of that green base. Okay, the green base. Now the base is a rectangular prism, right? It is a rectangle. It's just very, very flat, but that's okay because we're still going to use this length times width times height formula. And I'm going to have 24 times 24 times 1. And we can pull open our calculator to help us do that. And I get 576. And then now let's find the volume of that yellow post on top. So again, it's still a rectangular prism, so we're going to do length times width times height. And we're going to be plugging in 4 times 4 times 72. We're going to type that into our calculator. I get 1,152. And then since it's a composite figure, our very last step would be to add them together. So 1,152 plus 576. And when I add them together, I get 1,728. Whoops, so sorry. I'm a bit too close to the edge here. There we go. So final answer for this figure is going to be 1,728. And again, you have to keep an eye on those units. Okay, the course loves to give you mixed matched units, so make sure that you're reading what the units are in the final answer. Right here we want inches, you also see inches here, and make sure that you are converting before. You must convert before you find your volume. Alright, number 10. So 10, it says that Brad needs to find the volume of the following composite figure formed by stacking a triangular prism on a rectangular prism. All the measures shown in the figure have centimeters as their units. He found the area of each face, then added them together. Is Brad's solution correct? Well, think about what we did when we did surface area, right? With surface area, we found the area of each of the faces and then added them together. Here, Brad needs to find the volume, right? And finding the volume, you just multiply the three numbers that you have, you plug them into your formulas. So it looks like he did not find the volume, he actually found the surface area by mistake. So no, he mistakenly found the surface area of the figure instead of the volume. So he just maybe read the question a bit too quickly, or just got ahead of himself, or maybe he just really likes finding surface area, and so he wanted to find the surface area instead of the volume. But that doesn't work here because we got to find the volume, right? All right, number 11. So 11 says that a community swimming pool is a rectangular prism shape that is 30 feet long, 12 feet wide, and 5 feet deep. A wading pool is half as long and half as deep as the larger pool. How many times greater is the volume of the swimming pool than the volume of the wading pool? Okay, so let's kind of have this separated here. Oops, I still have my eraser. So here we have our swimming pool, and we are going to use length times width times height. The dimensions of my swimming pool are 30 by 12 by 5. Okay, and then I have this wading pool down here. And I'm still going to do length times width times height. However, it tells me that in that wading pool, the wading pool is half as long, right? So this 30 here that relates to how long it is will be cut in half. So instead of 30, I'm going to have 15. And then it tells me that it's half as deep. So this 5 feet depth is going to be cut in half. But it doesn't say that my width or how wide it is also cut in half, right? It does not say that. So I am not changing that 12. However, I do need to change this to 2.5. Okay, so again, I cut in half this 30 and this 5 because it tells me that it's half as long and half as deep. Okay, but it did not say anything about the width or how wide it is, so that is why I kept that 12 the same. Alright, so next step is going to be to multiply these to figure out what our volumes are. So 30 times 12 times 5, and 15 times 12 times 2.5. So this gives me 1800, and this gives me 450. I want to know how many times greater is the volume. So to figure out how many times greater, the last step we would need to do is division. So we're going to divide our bigger number on top. So 1800 divided by 450, and I get 4. So that tells me that the swimming pool is 4 times larger than the wadding pool. So it's 4 times larger than the wadding pool. Alright, next one. So we want to know what is the rectangular prism, or what's the volume of this rectangular prism in cubic feet. Notice how I have yards here. I need to change those before. So if you don't know, type into Google, right? You have Google for everything, even for volume formulas if you forget them. There are 3 feet in 1 yard. So to convert these, I'm going to multiply both by 3. And then I just need to multiply all of them together. So 9 times 6 times 9. And let me pull open a calculator. And I get 486. So 486 is going to be the volume of this rectangular prism. Alright, I need 3 more. Okay, so here James is building a birdhouse, and it's made up of a rectangular prism with the triangular prism stacked on top. So these are the dimensions that it gives us for the rectangular prism and the triangular prism. We want to know what's the volume. This is actually nice because I can just plug all of these into my formulas and then add them together. So for my rectangular prism, I can just do 4 times 7 times 11. And for a triangular prism, we haven't worked with that formula very much. It's 1/2 base times height times height. So the only difference is that there is a 1/2 because we have a triangle. So let's type both of those into our calculator and then add them together. So I get 462. So it looks like you were very close here. You just forgot to find the area of that triangular prism and then add them together. So 462. Alright, 14. So let's see, we have these stacks here, and so there's 6 identical boxes, and the overall dimensions are these. What is the volume of a single prism? Okay, well, if this is the volume of all of them, right, to find the volume, 24 times 24 times 6, and then since there are 6 identical boxes, all we need to do is divide it by 6. So I'm going to take that 3,456, divide it by 6, to get 576, because there are 6 equal boxes. So 576 inches cubed is how much volume each one of these individual boxes have. Alright, and then last one. So last one here is a triangular prism, and we want to know what is the volume. So we have 1/2 base times height times height. 1/2 times 13 times 13 times 6. Plug that into a calculator. And I get 507. So very, very close here. Don't forget that you need to divide it by 2 or include that 1/2. Okay, triangular prisms, you have to have that 1/2 in it as well, because that is a part of the formula. But yeah, that last one is 507, and once you have typed that in, you are good to submit.